All right, let me start by thanking Lilian and her colleagues for organizing this workshop. I know this is always a tremendous effort, and thank you for inviting me to give this talk. I've entitled it Developing Sign Language Technologies for the Users, Insights from an NLP Perspective. NLP, Natural Language Processing, is where I come from. And I'd like to start by giving you an overview of some of the projects in the area of sign language technology that I am involved in. The first is an EU H 2020 project, which is entitled Easier, and it deals with automatic sign language translation. Among the 14 partners of this project are some institutions which likely you will be familiar with, such as the University of Hamburg, Radboud University, DECAL as part of University College London, University of Surrey, CNRS, Interpretis, and also Swiss Text, which is a subsidiary of the Swiss Broadcasting Corporation in charge of providing accessibility services on TV. The second project is a large-scale project which I'm leading, which is funded by the Swiss Innovation Agency, and it's called Inclusive Information and Communication Technologies. The project is subdivided into 5 sub-projects, of which 2 are related to sign language technologies. One is on automatic sign language translation, and the other is on automatic sign language assessment. And here too, we have a consortium of different partners, of which University of Surrey is, for example, a foreign partner. And we also have the Swiss Federation of the Deaf on board and Swiss Text, whom I mentioned previously. And the third project is a second of 2 projects that deal with automatic sign language assessment, which involves enabling hearing adults learning sign language, in this case, Swiss German Sign Language, the sign language of the German-speaking part of Switzerland, enabling them to learn sign language using technology assistance. And what we did in SMILE 1 is we developed a prototype of a system that gives feedback on the correctness of the manual parameters, so of the manual parameters of signing. So for example, hand shape, hand position, location and movement. And now in SMILE 2, we're going beyond the isolated sign level to look at signed sentences. And here then, of course, what becomes very important are the non-manual aspects of signing. So I want to dedicate the rest of my talk to sign language data, because if anything, what I found to be very important in the past 10 years of my research in the sign language technology area is you really need to know your data. And ideally, you would create the data yourself. You would record it yourself. And this is what we're doing in the SMILE 2 project, where we have a studio at the University of Zurich, which with the support of our colleagues at the University of Surrey, we equipped with different cameras, and also Surrey developed a recording interface so that we can capture the signers from different angles and with dedicated cameras so as to arrive at high quality sign language data. Now, many of you will be engaged in the deep learning community, and you know that you need lots and lots of data, and the amount of data that we can capture at this point is very limited. So likely you will look at relying on data that has already been created previously. And the community that I come from, the machine translation community, has undergone a very important shift around 2016, namely that of traditional statistical machine translation to neural machine translation. And what we observed was a huge gain in performance in changing paradigms, but this came at the cost, and it came at the cost of requiring even more data. So neural machine translation systems are decidedly data hungry. And I know that the same is true for computer vision, which this conference is a part of. And so what we have typically on regarding spoken language machine translation systems, so spoken languages as any languages that are not signed languages, is we have systems that are able to rely on data sizes on the order of 100 million of sentence pairs. Now, this is not the amount of data that we have available for sign language machine translation systems. One of the most popular data sets is the Phoenix data set that was created by colleagues at the RWTH Aachen in Germany and later refined by colleagues in Surrey, and is now called the Phoenix 2014 T dataset, T for translation. Now, even the creators of this dataset will agree with me that firstly, of course, this dataset is limited in size because it only holds around 8,000 sentence pairs, and it also has a number of additional shortcomings. One, it only focuses on a very specific domain, that domain of weather reports. And secondly, the dataset consists of annotations, or I should say transcriptions, gloss transcriptions, that are known to be very limited in scope. So sign language glosses are a very restricted way of representing sign language, and they don't account for all of what is inherent in signing. And so what we found very important in my group is to look at exactly the data that we want to work with, and to widen the scope from weather reports to general broadcast data, and to characterize the different data sets that we have available along different aspects. And I want to give you an overview of these aspects. So it's very rarely the case that sign language represents the source of a data set. It's most often the target. We have one program on Swiss TV that actually has sign language as a source, and that's it's called Sehen statt Hören. And I know that similar programs exist in Germany and also in the UK, where it goes by the name of See Here. But most often, sign language is a result of either an interpretation or a translation process. Interpretation, where we have a live scenario, and translation, where we don't have this, this live scenario restriction. And our deaf translators here in Switzerland that operate in the TV domain most often have as a basis a video containing spoken language with associated spoken language subtitles, and the subtitles are then what they would take as a basis for their translation process. And what they would produce typically is a gloss script. I know this is different from country to country, but here in Switzerland, they produce gloss scripts. And in the case of subtitles as a basis for translation, they would produce timed glosses, so essentially gloss subtitles. What is less often the case, especially in the broadcast domain, is that they would have a spoken language text and then translate this into a gloss script without any timing constraints, so where they wouldn't have to fit the final translation product into a pre-existing video. And turning to signers, we can have either deaf or hearing signers. And in narrowing down to the interpretation scenario, we can have three different modes of preparation. We can have the case where sign language interpreters, be they hearing or deaf, can have no materials ahead of time. They can have some materials ahead of time, or they can have the entire episode ahead of time, which then of course leads to the highest quality of the interpreting product. And similarly, we need to look at how the subtitles were produced. So we can have entirely pre-produced subtitles, which again, similar to what I said before, would then result in the highest quality of subtitling because there is no timing constraint. We can have hybrid or so-called semi-live subtitles. This is the case, for example, in Switzerland in the daily news. So part of the daily news consists of pre-produced subtitles, and other parts, specifically where we have live interviews, are based on live subtitles. And in Switzerland, and I know that's also the case in other countries in Europe, live subtitles are produced via re-speaking. So we have a human subtitler who is typically a trained spoken language translator, re-speaking the speech into a speech recognition engine, which then produces an output that can be post-edited by the human subtitler for a certain amount of time, a very restricted amount of time, usually 1 or 2, 3 seconds time to correct the output of the ASR of the speech recognition engine. And then we can have subtitles that are entirely live. And of course, live subtitles are bound to contain mistakes, either on the part of the human subtitler or on the speech recognition engine. And lastly, it's important to look at the relation between the subtitles and the signing, because ultimately what we want to end up with, either as a basis for training sign language interpreting, sign language recognition models, or training sign language translation models, is parallel data that consist of spoken language subtitles, perhaps even segmented into sentences, and sign language videos segmented into smaller units as well. So most often it's the case that subtitles exist prior to the signing in the broadcast domain. But we have a few instances where the signing is produced and then the subtitles are created based on the signing, in which case the timing can be adjusted to that of the signing production. So this will yield, again, higher quality than if the subtitles were existing prior to the signing, and the signing was also produced in a live scenario, for example. And then a third option is where we have pre-existing subtitles and then we produce a signed translation, for example. And then as part of the TV production process, we are able to post-adjust the timing of the subtitles to fit the signed production. So this again then yields a comparatively high quality for our data. Most of the data that we have available, at least for the Swiss context, is data by hearing sign language interpreters, and this data will then have what's called an alignment offset. So typically we have the speech of a moderator, and then we have the signing that starts, and then after some time we have the subtitles. It might also be the other way around. And what we're doing is we're basically ignoring the speech, and then we're pairing the signing with the subtitles. And between those two modalities, we then have an offset that is most pronounced in an interpreting scenario, less so in a translation scenario. And these shifts, this offset in alignment, we need to take account of. And we do that by either establishing an automatic post-alignment routine, so a routine that is capable of adjusting the natural alignments present in an interpreting output, or we do so by manually correcting these alignments. And this is done by adjusting the starting and ending times of subtitle. Here you see an example of us doing this in a software that was developed at the University of Hamburg, ILEX, a transcription and annotation software. So this then yields comparatively high quality data, and we distributed such data as part of a shared task on machine translations that we are currently involved in, based on prior work also by our colleagues at the University of Surrey. So this data is freely available, and I invite you also to have a look at the share task that we are organizing. So what do we do with this data now that we have an understanding of the quality of different types of data sources, especially within the broadcast domain, such as I've just outlined? What we can do is, because we said earlier that we need large amounts of data to train our deep learning models, is we can look into combining different data sets. So we have comparatively large amounts of interpreting data, and we might combine this with deaf translator data, for example, as part of a pre-training and fine-tuning scheme. We might also apply an existing pre-trained model and fine-tune it on data from deaf translators, for example, or apply other combinations of data sets. And that concludes my overview, my talk. And the main message that I want to convey is that it's very, very important to familiarize yourself with the data you're working with, and to not just take any pre-existing data set and apply it as part of deep learning research, but to really get to know your data, either ideally create it yourself, or at least use pre-existing data and know about its precise characteristics along the dimensions that I've outlined. Thank you very much for your attention, and I look forward to the Q&A session.